Question 120, it's a question about binomial expansion, would you believe? So I'm finding the first three terms in the expansion of 4 plus x to the power of a half. Now the formula that we're using must have a 1 here. So what I'm going to do is I'm going to say, well, 4 plus x is the same as 4 times 1 plus a quarter x. And so 4 plus x to the power of a half is the same as 4 times 1 plus a quarter x to the power of a half. And that's the same as 4 to the power of a half times 1 plus a quarter x to the power of a half. And of course this is just 2. So writing that rather more neatly, we get 4 to the power of a half times 1 plus x over 4 to the power of a half. And now I can apply the binomial expansion formula to the bracket here. And not forgetting that when I do that, I'm then multiplying by 4 to the power of a half, which is 2. So there's my approximation when I tidy that all up. Now I've got to state the set of values for which the expansion is valid. So we've used the expansion on this bracket here. So that means that the value of x over 4, the modulus of that must be less than 1. So that means that the modulus of x has got to be less than 4. So now we've got to find a suitable value of x to find an approximation for the square root of 17. It looks a bit strange, doesn't it? Now, what I'm looking at here, 4 plus x to the power of a half, I'm looking for a number which would start to give me this 17 that I'm looking for. I might experiment with a few values of x equals 1 or 2, or actually I can't go very far because I've got to be less than 4. None of those would be any help, so I'm starting to then think of fractions. And the fraction that makes sense is x equals a quarter. Because a quarter, when we say 4 plus a quarter inside the brackets here, that's the same as 17 over 4. And so that's where my 17 is going to come from. It's worthwhile checking that the value of a quarter is actually a valid value of x, which it is. So when I put x equals a quarter into this expression, I get 17 over 4 to the power of a half, which is root 17 over 4, is equal to this thing here. And of course, the square root of 17 over 4 is the same as the square root of 17 divided by 2. So that's what the square root of 17 over 4 is. So therefore, the square root of 17 is, I multiply that by 2. So there's my approximation for the square root of 17. Okay, a bit tricky that one. Hopefully you got on all right with that.